Fifth grade, we have a cool lesson today, and it's all about the triangle. It's all about that angle, So, an angle, I'm going to use in blue to show you what an angle of a triangle is. They, they show angles using this. An angle, an angle is where two line segments meet together. They meet at a vertex. And the vertex has two or more that come off of it, and those two lines or line segments form an angle. So they show this curved line through it, meaning that's an angle, okay? And an angle can be measured by using what's called a protractor. In a protractor, you place the center middle right on the vertex, and you line it up with one of the lines here, and then you take your other side and you can measure what degrees, how many degrees of the whole circle the angle is, and this would be a 60-degree angle. So this angle is 60 degrees. This should be another 60-degree angle, and this should be, then if that's a 60, this is a 60, then that should also be 60. Yeah, all of them should be 60 degrees, because the inside of a triangle is always 180 degrees. Did you know that? If I add all three up, it should always equal 180 degrees. Ooh. Christopher's like, I don't believe you. So, Christopher doesn't believe me. Well, mhm. So this will say, that's going to say, well, 180, that's going to say 120. 119 because I measured it off. So it's 120, meaning that inside is 60. And then if I do the same thing up here, which I don't know if this is going to let me rotate it. I know. Yes, it does. Where'd it go? Oh, so no, it was 61 degrees because it wasn't perfect. You see, my line's off a little bit. So 60, 60, 60. There, I win. All right, but those are angles. Well, 6 plus 6 plus 6 is 18, and 18 at Carapet is... I can add, Kalen. All right. So, what kind of angle is this? And you'll notice that most likely it'll be like, it'll have a box like this, and on the inside, what do we learn? What kind of angle is this, Rebecca? A left angle. Good. No, I'm kidding. Yeah, it's a right angle. A right angle. What about this one? What kind of angle is this right here? Grace? Yeah, it is an acute angle, just a cute little guy. And what about this one? Adam? Obtuse. Yeah. So I'm going to close these ends in to make a triangle, because triangles have how many sides? 3 sides. Good. So we can classify or name triangles based on their angles, their main angles. And because this has a right angle, can you guess what kind of triangle it is? A right triangle. What about this one? Hold on. This is going to be even tougher. Ready? So, because this not only has one acute side, but it... Oh, I didn't make them all acute. Yeah, and if all 3 angles are acute, which I didn't do on this one, I will. I'm gonna change it here. I'm going to. How in the world? There. I'm like just butchering this now. There. There. If all three angles are acute, that's not even acute. There. All right. So if all three angles are acute, this would be called what kind of triangle? Good. It was. It was harder than it looked. And then if one of the angles is obtuse, we label it as an obtuse, Kaylin, an obtuse triangle. So that's classifying it by the angles. So if they say to classify this triangle based on its angles, what kind of triangle is that? Acute triangle. What about this one? Oh, that's the same. All right. What about this one? Obtuse, because it's got one obtuse. Good. What about this one? Rebecca? All right, because it's got a right angle. Good. We can also classify a triangle by the sides. If the sides are all the same length, like this, all the sides are exactly the same length, we label this as, yeah, an equilateral. An equilateral triangle, meaning that all sides are equal. And we can show that by putting like two little tick marks on all of them, meaning this side's the same as that side is the same as that side. Okay? Now, if only two of the sides are, if at least two sides of the triangle are the same, like in this one, this side is the same as this side, but it's different than that side. This is called, Christopher, isosceles triangle. So isosceles means that at least two sides are the same length. Now, if all three sides have different lengths, such as this one, that's not going to be it. Let's draw this by ourselves. 1, 2, 3. Those all have three different sides, different lengths for each side. This side is different than this side, which is different than that side. Okay? Because it has three different sides, this is called a scalene triangle. Just different. Okay? Any questions on classifying by angles or by sides? Grace? Good point. How do you know if it's an equilateral? Let's get an equilateral up here. It'll look like an equilateral triangle. How do you know exactly? Three acute sides will help you. If it doesn't have an acute side, it won't be. They're not all going to be equal. So if any right triangle, like this, these sides might be the same, but that side's different. It's geometry. It's called the hypotenuse. We're not going to get into that right now. You just know that if you have a right angle, a squared plus b squared is going to equal c squared. Don't worry about it. All you need to know is that if it has a right triangle, that side is longer. Okay? For sure, right triangles. Otherwise, you can bust out a ruler. But if it's all three acute sides, the textbook will make it very clear that it'll say equilateral. Okay? All right. Um, can an equilateral triangle have parallel sides? No, because then I couldn't close it in, could I? If they were parallel, I couldn't like take one line and make a triangle, no matter what I did. Um, yeah, weird triangle. So look at example 1. It says all three sides of this triangle are congruent. Remember that key word, congruent. All right, so example 1. It says all three sides are congruent, and the congruent means they are the same, right? Which of the following terms does not describe the triangle? Is this an equilateral? Yes. Why? They're all the same. They're all equal. Are they all acute? B. Yes. Is it an isosceles triangle? What is the term of an isosceles? At least, Christopher? Uh-uh. Uh-uh. At least two sides are equal. Could all three sides be equal for an isosceles triangle? Yes. And letter D says right. Is this a right triangle? That is the only one that it is not. It is not a right triangle. Okay? So if you look back, Christopher, on page number 223, underneath triangles classified by sides, the second sentence says at least two sides of an isosceles triangle have equal lengths. So all three sides could be. Okay? Example 2 says to draw three angles with sides that are segments of equal length. Make the first angle acute, the second angle right, and the third obtuse. Okay, so what they want you to do, the first one to do acute, but they have to be the same length, right? Bless you. So we're going to infinite clone this one. Boom. And then this still isn't going to work. But we have acute. And then we're going to have a right. And then we're going to have an obtuse. Then it says to close her in. And what kind of triangles do you have? So this one would be acute. And what else is it? It's acute and it's also isosceles. What's this one? Right, and what else? And this one? Obtuse and isosceles. Because they all should have two sides that are the same length. Good. So, if at least two sides are the same, it's isosceles. If all three are not the same, so I'll do one of those. So, this is what kind of triangle? It's a scaling, and what else? Shh. And what else? Who can figure this one out? Shh. Christopher? Obtuse. Because in acute, it has to have all three. Look at this angle here. Ah, this would be a right if it was, or a right angle, and acute would be smaller, but it is way larger than an acute. Classify your triangles A, B, C, D, E, F, and then draw some figures on G, H, I, and J. Okay? practice in lesson number 36 for next time.